Hi, and welcome to another video. Today I would like to have a quick look into the type system and more specifically into the dynamic type in Flutter or in Dart actually. Let's start at the Q&A section at the Dart language website, where you have the questions about types, and there is a question, is Dart a statically typed language? And they're answering us that yes, Dart2 is a statically typed language. For more information, we can also have a look there in a moment. So a statically typed language means basically that the types are known on the compilation time. So the compiler knows that some variable, for example, is of a type string, and only a value of this type can be assigned, in this case, to a string. So if we have an integer, we cannot assign a double to it, because a double is not an integer. But of course we have inheritance, so if you have a type num in Dart, which is the type that is extended by a double and a num, then we of course can have a num and then assign a double and an integer to it. But if you have a look at this answer further, they are saying that with its combination of static and runtime checks, Dart has a sound type system, which guarantees that an expression of one type cannot produce a value of another type. No surprises. In the next sentence, they say that even with type-safe Dart, you can annotate any variable with dynamic, if you need the flexibility of a dynamic language. And now, they say that dynamic itself is a static type, or is static, but it can contain any type at runtime. So dynamic type is actually a static type like any other type in Dart, but it's a special type which allows you to have any type, which actually makes it a dynamically static language when you are using dynamic. Then let's have a look how dynamic actually works. For that, I have a small application prepared over here. It's a simple Dart only application, no Flutter in here. Let's start maybe with a simple situation where you would usually use dynamic type or have dynamic type for your application. So a typical application in Flutter would be a UI, and it would access some kind of an I/O. It will probably have some remote endpoints, which would have some REST or GraphQL API, and that API gives you some data. And that data frequently is in the format of JSON. So you may have the following response from your API. Let's say string dynamic data, and this will contain, let's say, a name, and the name will be John. And this is some, let's say, that there is a user endpoint, and this endpoint gives you just information about the user. And then you will have your data layer. In your data layer, you will have some interface. So usually, well, it's actually implemented. So we don't have interfaces in that, remember? So we always use abstract classes. We will have some mapper from to, and this mapper will usually have one method, which is to map from, and that's your interface in the data layer. And then you will have your specific class, your specific mapper. So in our case, this will be a class user mapper implements mapper, and then we also have to give it a type. So we are mapping from dynamic to, let's say, some kind of a user. We will create it in a moment. Now this of course needs to implement that one method, and here let's say that we will just return our user, and the user will have from and name. So from name we will, also here we have to define the user. Okay, let's quickly create the user because it's complaining about not having it quite a lot, and it will have only one string name. And we need a constructor for that. There we go. And yeah, this should be from. Okay, so this is a very small implementation of how your usual mapper will work, but basically you have, of course, your interface. So to make it maybe more of a real example, I've also implemented interface over here. And then you will have your actual mapper, and this mapper will create your user domain class, which usually will sit somewhere in the domain. And then you will map from something to the user. Depends on your architecture here, of course, so it can be more complex than this. And finally, let's have over here, let's print our mapper, user mapper dot map, and let's give it the data. How about we run it, and we got an instance of user. Let's just print the name of the user. There we go, we get a John. And this will work as long as this is a string. Now, if it's 12 instead, because API changed and now names are numbers, because why not? We are a progressive society, now everyone is called by a number. We run it, boom, and we get an exception. And the exception says type int is not a subtype of string. In other words, we can try and catch this, or there are other ways to handle this kind of situations, but we have to be very careful with the type dynamic, because the dynamic is able to have everything in it. So it's any object, any class, any type that we have in our type system can be assigned to the type of a dynamic. And then, of course, when we try to assign it to a string over here in the mapper, it will not work. Let's have a look at a different use case. Let's remove all of that. And let's say now we will have some class. Class call me. And this class call me has a method. Let's say the method is just void calling. Okay, so we have a method called calling, and let's print calling over here. Let's now have in mind dynamic. Let's call it a call me. And now, of course, as you would expect, we can call the method calling on this type. But notice that already the interpreter doesn't really know that I can call the calling method on call me over here. So it is not able to interfere the type of this call me variable over here. So I can still call it. There we go. So I'm calling on call me. Let's run it. And I'm getting my string printed calling. Since the interpreter and the compiler, they just don't know what this type is, even though I have expressed this over here, I have no problem with, instead of calling a method, not calling. And you see, I don't get any error right now. And in compilation, if we run, we also get an error. The error is at runtime. But we have a receiver instance of call me, and then we have tried calling, not calling, which is of course not possible in this case, because this class doesn't define such a method. And in case we would have, instead of dynamic over here, final or variable, then you can see that we immediately get a message over here with an error that the not calling isn't defined on the type call me. Because if it's not dynamic, then it cannot be anything at runtime. And therefore the compiler can actually know that this is of a type call me right now, because at the time of assigning, it becomes type safe. In the end, let's have a look just at a very small other thingy. Let's say we have an interface. And let's say this thingy wants to have one method. Let's say a void method or int method, and let's say it has one argument which is of type string argument. Okay, so here we have an interface. Now let's say we have a class called implementation, and this class will now implement like this. And of course, if we are implementing an interface, now we have this method without a body in the interface, which we have to override. And let's say we will print our argument over here. So far so good. And we of course have to return some integer because that's what we defined. Okay, and now let's create it. So let's say final implementation, and let's call our method. There we go. We have a complaint because we need of course to supply it an argument, which is a string, some string. All good. Let's run that. There we go. We get our sum string. So everything is as expected. But now there is one small thing. This method over here can override with a type dynamic. So the parent type, it defines this method with an argument as a string, but there is no problem to override this method. And this is the same method overridden, so we don't have any issue over here that we have to override anything else. But we are now defining this argument as dynamic. And now we can pass an integer over here. We can run this and we are printing the integer. So let's say we would have some other class, let's say XX, because I ran out of names. And then let's say that this class will take our interface I as input, so we will have some kind of a delegation happening over here. Let's have a constructor for that. And now let's say that we have some final xx equals xx, and now we pass implementation over here, which is an interface, but of a type of implementation right now. So let's say here we have in this constructor maybe somebody. It will expect a string. And this will all work. So now let's maybe get rid of this method call over here. There we go, and we print in a string. Okay, string is again not the best thing to print. Let's print out string 1, 2, 3. There we go, and it works because, of course, now dynamic is more powerful, if we can say so, than a string. So it can take many things, but it can also take a string. So every time we will call on this interface that is expecting a string, but it's actually a dynamic in your actual implementation, then it will be okay, as long as, of course, you handle the dynamic type over here. I think that's enough for today, and that was a little bit look into the dynamic type and maybe why it's not recommended to use it, or what kind of benefits do we have if we use every variable statically typed or having the type interfered. Bye bye.